So today, guys, we're going to go through the 4 times table a little bit. And the first point I want to make is that learning your 4 times table by heart is by far the most efficient way to get yourself around it. So we'll make that our first point. Learn the tables by heart. Now, along with that, there's a few little tips. How do you know if your number that you're practicing is even in the 4 times table? Well, any number that's in the 4 times table will always end in an even number. It ends in an even number like 2 or 4 or 6 or 8, you get the idea. So if you've calculated something or you're trying to remember something and your number does not end in an even number, you know you're not on the right track. So how does that help? Well, that instantly eliminates half the numbers in the universe. So if you can say, well, in my 4 times table, I've ended it with a 3, it's probably not quite the right one. So that's your first tip for the day. Another nice thing with the 4 times table, you know that it goes like this. You've got 4, and then 2 times 4 is 8, and 12, and then 16, and 20, and so on. These happen to match the years that the Olympics fall into. So we had Olympics in 2016 on a leap year, and then we have Olympics in 2020. The next one, of course, will be in 2024. This one is Tokyo, I think, and I can't remember where the 2016 ones, but you get the idea. So the 4 times table matches the leap years as well. So that's another little tip to get your head around the 4s. The next little tip for you is to double the double. I'll quickly write that down for you. So what do I mean? Well, say you come across a number that you're not quite sure. Say you want to go 4 times 8. That's one that stumps some people. They go, oh gosh, I can't remember what 4 times 8 is. I've been doing my times table practice and it's just the one that falls out of my head the whole time. Well, here's my little tip. You'll know what double 8 is. You'll know that double 8, 2 times 8, is 16, right? So then, to get your 4 times table, you just double it again. Because 2 times 2 is 4, right? So if you double it and then double it again, you'll get the 4 times table answer. Double 16, of course, being 32. 4 times 8 is 32. Now that works with all of them, and it's quite a neat one for working out bigger ones. I'll show you what I mean in a sec. Say your number's a bit bigger, like 21 times 4. Now, this is a way you can do it in your head. Quite a handy little trick, doubling the double again. We know that double 21 times 2 there is going to be 42. And then, because we've already doubled it here, we only have to double it again to get our times 4 answer. 42 times 4 is 84. So we've worked out 21 times 4 without having to do any extra particular work. Now I'll show you how to do an algorithm as well, but that's handy for really big numbers. If it's a handy sort of 2-digit number like this that's easy to double, it'll also be easy to multiply by 4. So have a go at this one for yourself. We've got 32 times 4. Now you can tell straight away that double this is going to give you some number in the hundreds, but don't worry about that, just take it step by step. So in your head, first of all, multiply that by 2, see what you get, and then double it again. to get your final answer. You can pause the video here if you like, work it out, see what you come up with. How did you go, guys? Well, double 32, obviously nice and easy, 64. Didn't require any particular extra skills. We know double 4 is 8, so we've got our 1 sorted out already. Double 6 is 12, so it's 12 tens or 120. 32 times 4 is 128. Now, if you've dealt with computer things, you'll recognise these numbers because they go up in increments like that. So you'll have the next megabyte thing they have is double that again, which of course is 256, and then they double it again to 512, and so on and so on. So it's not, these are numbers that you might recognise from memory sticks and that sort of thing. All right, have another go with this method, and then I'll show you something else. Okay, so a new question for you. What is 52 times 4? Double the double. See how you go. Pause it here if you like, and I'll come back to you in a sec. Okay, hopefully you've had enough time. Double 52. Easier to not split it up, but we know it's 104. 104 like that. It's doubled. Oops, times 2 down there. Then we're going to multiply that by 2 again. It seems hard, but it's really not. It's going to be 208. So, a nice easy method that you can do in your head for many of these 2-digit numbers. The mystery is all gone. Now the next one I'm going to show you, we'll go through some algorithms because they work for more complicated numbers. So have a look at this one, guys. Now this is a method we've played with before, so you should be a little bit familiar with it, but it does require that you know your times tables up to about 12 already, because that radically simplifies what we're doing here. You don't have to do much working out. Because as with all of these kinds of methods, what we're doing is taking one slice at a time and then just adding the results together. So for example, I know 4 times 7 is 28, so I put my 8 down there. Here's the important bit to remember: carry the 20 or the 2 tens up above those other 5 tens there. I know what 4 times 5 is, that's 20. Then I add that 2, that's the important bit. So it becomes 22 tens in this case. Put the 2 tens there and the 20 tens up here with all the other hundreds. 4 times 3 is 12 plus 2. End up with 1,428. That's 14 hundreds, right? 4 times 3 plus 2 hundreds. So pretty straightforward. It's remembering to carry the number that into the right place and then knowing what to do with it. You add it, in this case, after you've multiplied the other number. It's really easy once you get the hang of it, and it's a really nice, reliable method for doing basically any size number. I could multiply using this method. Even if this was 10 digits long, I could still multiply it by 4 using that method and only know my basic facts up to 10. Alright, let's have another go. So here's another example. This time the number's a bit bigger, but as I mentioned before, that's not a problem. Take a chunk at a time, see how you go. Pause it here if you want to have a go for yourself. Otherwise, just keep watching and I'll show you how it works. Okay, so 4 times 5, 20. You know that? Put the 0 there and the 2 up in the tens. There's no other tens. 4 times 0 is 0. So I just add the 2 and pop that down there. 4 times 7. Do you remember that one? 28, you say. Brilliant. Absolutely right. So there's nothing to add to it there, so I can just put the 8 from the 28 here. It's 28 hundreds actually. So these 20 hundreds go up here with the thousands. 4 times 6 is 24, then 24 plus 2 is 26. So my total number, sometimes people put a little comma there to indicate the difference between thousands and hundreds and ones. So I should have 26,820. You can get to very large numbers quite quickly and easily using this method. What if there's a decimal in the number? Well, we've talked about this plenty of times before in class, but it's actually no problem. Because it's all decimal, the numbers work in exactly the same fashion. The only thing you need to remember to do is pop your decimal point down there straight away. I would do that anyway. What that means is that you don't forget to do it later and you keep your place values correct. Otherwise the maths works the same. Again, pause it here if you want to have a go for yourself and we can check your answer in a second. Okay, 4 times 6, easy, 24. Now that's 4 tenths. The two whole numbers that I've ended up with go up in those 1 columns there. 2 times 4 or 4 times 2 is 8, plus 2 is 10. Nothing to go in the ones, 1 10 goes up with the other 10s. 4 times 3 is 12, 12 tens in this case, plus 1, 13. End up with 130.4. Now if there wasn't a decimal point there, it would be 326 times 4 equals 1304. The maths works exactly the same. The only difference is we've got a sneaky little decimal in there. What if you've got this sort of thing? You're multiplying by 4, but it's 10 times 4 already. You've got 74 times 40. You know the number's going to be quite big. Well, here's a tip for pros. It makes it super duper easy. When you're multiplying by 40, it's actually the same as multiplying by 4. All we have to do is remember to change our place value before we begin by putting that 0 there so that everything is 10 times larger when we work it out. So in this case we'd go 4 times 4 is 16. 6 goes there and we carry the 10 up with the other 10s. 4 times 7 again 28 plus 1, 29. The number ends up being nearly 3,000, 2,960. Really handy tip, didn't require any extra work except that we put that 0 in first to indicate that there's going to be no ones. What happens if your teacher's trying to be super duper mean to you and gives you a number like this? Say like 819 times 44. Well, straight away, you know the number's going to be big. The answer's going to be a big number. But how can we work it out without straining the old brain too much? Well, again, it's about taking it chunk by chunk. So, have a think about it. Pause the video here if you want to have a go by yourself. Otherwise, keep watching and I'll show you how I would do it in an easy way. First thing I'll do is take the 4, just multiply by 4 to start with. So 4 times 9 is 36. So I put my 6 there, carry the 3 tens. 4 times 1 is 4, plus 3 is 7. 4 times 8 is 32. There's nothing to carry, so I can go 32. So the first part of my answer is 3,276. Now, all I'm doing is multiplying by 40. But we've already done the work. All we need to do is remember to put our 0 there and transfer these numbers across. So 6 goes there, 7 there, 2 there, 3 there. We can add those because the maths is the same. We don't have to do it all over again. Might have to move this up a bit so you can see the answer. Adding those together, now you've done algorithms like this before. 6 and 0 is 6. 6 plus 7 would give you 13. 3 there, carry the 1. In this case you add them all up. So 1 and 2 and 7 is 10. 0 is there, carry that up into the thousands. It's basically 3 plus 3, isn't it? So it's 6. Oops, pen went a bit funny. And then nothing to add there, just pop the 3 down there. So my total number for 819 times 44 is 36,036. Quite an unusual looking number, but easy enough to do once you know a few tricks. Okay, have a go at this one for yourself. 492 times 44. Pause the video, have a look at it, write it down for yourself. See if you can multiply by 4, then multiply by 40, add the two together, see what you get. Okay, we'll do the hard work first. 4 times 2 is 8. Really not that hard. 4 times 9, 36. 6 goes there, 3 goes there. 4 times 4 is 16 plus 3, 19. So 4 times 492 is 1968. Makes sense. 492 is nearly 500. 4 500s would be 2000. It's less than 2000. Seems about right if we're going to approximate. Now, remember, 1968, that's a good year. Remember, we don't have to do the maths all over again. We can just pop a 0. 1968. And then we're just adding those together. 8 and 0, 8. 6 and 8, 14. Carry that one up to there, it makes that 10 and 6, 16. Carry that one up there, it makes that 11. Total answer, 21,648. Now, some teachers are mean. Teachers like me are super mean, because I might ask you a question like this. 15 times 0.4. We're multiplying by a number that's less than 1. Well, actually that's our clue as well. If we're multiplying by less than 1, think of this times as an of. It also means of when the number that we're multiplying is small, or a fraction. In this case it's 0.4. We could also say that we're looking for 40% of 15.4. We're going to chop, our answer is going to be less than 15. In fact, it's going to be less than half of 15, which gives us an approximation, a place to start. So what do? Well, as always with decimals, you do it in the same way. The maths doesn't change. We can still multiply, but we've just got to watch where our decimal point ends up. It's a little bit more mind-bending, this one. Hopefully you've had a chance to have a go. The first thing I would do is put a decimal point there so that we know that we're talking about a decimal number. It helps us to keep track. Otherwise the maths is the same. 4 times 5 is 20. 0 goes there, and the 2 goes above the next one that we're going to deal with. 4 times 1 is 4 plus 2 equals 6. So our total answer, now we don't, is 6 there, but we don't need that 0.0. We could also say, it's like that, but the 0.0 helps us to keep track of what place value we're exactly talking about. Now it seems ridiculous, doesn't it? 15 times 0.4 equals 6, but if you say 0.4 of 15 is 6, that makes sense. Half of 15 would be 7.5. This is less than half of 15. Kind of makes sense when you put it into that perspective. Okay, I'll give one for you to try. See how you go. Okay, you've got a meaty one there. See how you go. So pause it if you need to. Work through it. Come back and have a look. See how you went. Okay, so I'm going to follow my little guideline that I set there and put a decimal point there. 4 times 9, 36, right? in this case it's going to be 6/10 go there, and then the 3 will go up here. 4 times 3 is 12, plus 3 is 15. So 0.4 or 40% of 39 equals 15.6. What do I mean by percent? Well, percentage means that whatever number you have gets chopped up into 100 parts. So this would also be, you could say, 15.6 equals 40%. 40% of 39. Just swapping around a little bit. Percentages and decimals are very closely related. So, as always guys, have a bit of fun with it, experiment, play with the numbers. Check your answers with a calculator. Once you're getting into this kind of stuff, it's easy to get lost with your decimal places and your place values, that sort of thing. I would, in your maths books, always use your columns, because it's so much easier to keep track of where the place values are. So if you keep all of your 1s in a nice straight line, all of your 10s in a nice straight line, things tend to fall into place a lot easier. That's just a tip that people have been using since way back. Okay guys, thank you for being patient, and if you've got this far through the video, you've done extraordinarily well. Try some things out. Okay guys, we'll catch you another time. See you, bye.